Chemical rocket engines are an ancient technology. The great human and scientific achievements of our time, such as the moon landing in 1969, the Hubble Space Telescope, or even the New Horizons spacecraft, which showed us the beautiful red vistas of Pluto, all relied on chemical rocket engines, whose operating principles have remained unchanged for over 1,000 years. You see, in a chemical rocket engine, both the energy and the hot gas needed to make thrust come from a single source, rocket fuel. But the problem with rocket fuel is that you can only cram in so much energy before it wants to explode on you. So if you have a satellite and you want to go further into space, your only real option is to carry more heavy rocket fuel with you. But if you're carrying more rocket fuel with you, then you're bringing more weight with you. And if you're bringing more weight with you, then you have to carry more rocket fuel with you to bring that rocket fuel with you, and eventually the whole thing just kind of spirals out of control. And there are some places in the solar system that we can't get to because the whole spacecraft would be made out of rocket fuel. It's a horrible place that we're in right now. It's truly terrible. But there is hope. My dissertation research focuses on a new class of rocket engine technologies, electric rocket engines. Specifically, I work on Hall effect thrusters. If you're unfamiliar with what a Hall effect thruster is, I want you to picture in your head the glowy things that are on the back of Star Wars' TIE fighters and Super Star Destroyers. What's amazing is that those glowy things are not science fiction, but actual real rocket engines that we use today. Why, the images that I have up on the screen here is a picture of the Hall effect thruster that I used for my dissertation testing. You see, in an electric rocket engine, we're able to separate the gas source from the energy source, and we can create a very, very fuel-efficient rocket engine. For example, if we had a spacecraft going to the moon using an electric rocket engine, it could carry up to 3.5 times more cargo and payload than if it were using a chemical rocket engine. I mean, 3.5 times more cargo and payload. That is a huge increase. And we've had lots of great successes with electric rocket engines, but we've also had some setbacks with Hall effect thrusters. Specifically, they've gone up in space, and they've kind of operated abnormally, and that unpredicted behavior has led to some problems. And what we're finding out in my dissertation research is that the giant steel chambers that we test these rocket engines in are actually causing the Hall effect thruster to operate in a very particular way that it wouldn't do if it were operating in space. And the hope is if we can figure out what is causing this strange behavior, we can predict it, maybe we can even prevent it, and really push the boundaries and the state-of-the-art of rocket technology forward. I want you to think for a second about all the amazing things that we've done so far just using chemical rocket engines, okay? And now just try and imagine all the amazing accomplishments we could achieve if we started using rocket engines of a modern era and finally stopped using ancient rocket engine technology. Thank you.